Here we have an identity that we want to prove, and we are going to work with the left-hand side. So first of all, step number 1 says use an even-odd identity. And so we see we have a negative x for the angle here on cosine, and we know that if we have the cosine of a negative angle, that equals just the cosine of the angle. So we would need to enter in this first box this fraction, 1 over 1 minus, and it's cosine x without the negative. Now I'm going to also put in here, for entering in the computer, you need parentheses around here so that it knows all of that is in the denominator. Okay, after we've done that step, let's go look at step number 2, which says to get a common denominator. Now our fractions, both of them together, look like this, except this negative is gone. So the common denominator is going to need a 1 plus cosine x, and it's going to need a 1 minus cosine x. So I'm going to write that common denominator, 1 plus cosine x, parentheses around that, and 1 minus cosine x. And for the numerator, for the first fraction, it was a 1, and we don't have the 1 minus cosine x, so we need 1 minus cosine x. And now this would go in this first box, because notice there's a negative here and there's 2 boxes, but we need parentheses to show what's in the top of the fraction, the numerator, and parentheses around the denominator. So I'm trying to emphasize this because sometimes that's where the issue is at entering the computer with the parentheses. You can see right here I end up with 3 parentheses, 1 to close the argument of the cosine, 1 to show where the factor stops, and then 1 to show where the denominator stops. It is well worth writing down the steps on paper and getting your parentheses in, and then go enter it in the computer so that you don't miss one or lose one. Okay, that's just what goes here in this first box. Now in the second box with the minus, we still have that denominator, which was 1 plus cosine x. Gonna kind of have to squish it here. I think we can, I'm gonna put it down below 1 minus cosine x. And the numerator was a 1. We had the 1 minus cosine in, so we're going to need the 1 plus cosine x to get that common denominator. Now again, as far as parentheses to enter in the computer, you need parentheses around the entire numerator and parentheses around the entire denominator. So then that second fraction would go in this box. All right, so now we're ready for the next step. Step number 3 says subtract and simplify, FOIL the denominator. So as far as in the numerator, we have 1 minus cosine x, and this negative versus subtract, we got to subtract both of those, so that would be minus 1 minus cosine x over, and if we FOIL this denominator, first time first is 1, they are conjugates, so the outers and the inners will cancel, and then last times last is minus cosine squared x. Now it did say to simplify as well, so these will cancel. So as far as what I enter for a fraction, I'm going to have negative 2 cosine x, and that's going to be over 1 minus cosine squared x, and of course parentheses around the entire denominator. All right, now let's go to step number 4. And for step number 4, it says use a Pythagorean identity on the denominator. This is the denominator, and one of our alternate forms for Pythagorean identity, you can have it solve for sine squared x, and it equals 1 minus cosine squared x. So I'm going to leave the numerator alone, and then I'm going to divide it by sine squared x. So I replace this with that. Okay, now I'm ready for step 5. Write as a product of 2 fractions. Okay, so they already have the negative 2 in the computer, so that's going to be on the front, and I won't enter that. But this is, we've got a cosine x, and we can split that and leave 1 sine x, and then we can multiply that by let's see, let me just, so we can distinguish it, I'm just going to put a dot here. We could multiply that by 1 over sine x. Now, if you look here, they have parentheses for the multiplication. So in the first box, you could fill this in, and then in the second box, you could fill that in. Finally, step number 6, use reciprocal and quotient identities. So in this step, and as I look, it's already got the -2 multiplied out in front, so that's already there. This is a quotient, and it could be written as cotangent x, and this is a reciprocal. It could be written as cosecant x, and end up with this. And if we go back up to the top here, we see that is exactly what I was trying to verify that it equaled. And so I'm now done.